Hello everyone, welcome to CFD Verse. Today's topic is CFD interview questions for interns. So I have divided this video into three parts. First part, second part and third part. Each will be dealing with variety of CFD questions which will be important to know for any CFD beginner or the intern. So let's begin. Why every CFD engineer should know the basics? So basics are fluid mechanics, heat transfer, turbulence. Then variety of solvers which are used in the CFD are basics of the CFD. They are required because if you don't know them correctly, then your solutions may get wrong, and if you get the wrong results, then they are of no use. Hence the basics are important. So to have the right knowledge of the basics and then to interpret the results which you have been achieved after solving the CFD solutions, and if there are any problems you are facing, then how to troubleshoot them. So these all questions will be answered if you know the CFD basics. Hence this video covers all your CFD concepts which will be asked to you in the CFD interview, and so I will be answering them one by one. First question will be, what is the difference between laminar and turbulent flow? So laminar flow is a fluid motion where the fluid particles move smoothly in parallel layers. There won't be any disruption in between these layers of the fluid. On the other hand, turbulent flow is the flow which is very chaotic. So fluid particles will have the very random direction motion and they will form eddies and everything. So in engineering, generally what happens is laminar flow are very less in occurrence compared to the turbulent flows. In general, all the flows which you will be seeing in the real life scenarios will be turbulent flows. So these flows are determined on the basis of Reynolds number. So the next question, obviously, it is, what is the Reynolds number? So Reynolds number, first of all, it is a dimensional quantity, so which predicts the flow regime. So it tells you that your flow is laminar or turbulent. So when your Reynolds number is less than 2000, it means that your viscous force are dominating and hence it will be a laminar flow. When Reynolds number is in between 2000 to 4000, then it's the transition region. If the Reynolds number is higher than 4000, then it means that you have the turbulent zone, which means that the inertial forces are dominating the fluid flow and hence the flow will be turbulent. Next question is the Nusselt number. So what is Nusselt number? So first of all, to understand, Nusselt number is the ratio of convective to conductive heat transfer across a boundary. So if you have a Nusselt number of 1, it means that pure conduction will happen, and when the Nusselt number is higher, then you can conclude that your convection is the dominating part. So it is crucial to design for heat exchangers, cooling system, etc. Then the next question is, what are the modes of heat transfer? So basically we all know that there are three modes of heat transfer, which are conduction, convection and radiation. So conduction will happen when the heat is flowing from solid to solid or in between the solids, and whenever there is a temperature difference, the process of heat exchange will happen, which is the conduction for solid to solid heat transfer. Then the convection is heat transfer by the physical movement of fluids. So basically any type of air movement around the solids or heat exchange between the fluids, it will be called as a convection. Then radiation is the transfer of heat through electromagnetic waves. So radiation does not need any medium to transfer the heat. So in real world scenarios, multiple modes can act together, which means that conduction, convection can be together, or all three of the heat transfer modes can be act together in real life scenarios. So now what is the difference between the conduction, convection and radiation? So conduction is a heat transfer through direct contact. That means, for example, if you think a metal rod is getting hot at one end, then other end of the rod will be heated after some time. This is called as conduction. For the convection, you can have an example that when you feel a warm air from a heater or a cold air from your AC, then it's a convection. And the third example is radiation, which is sunlight warming your face, your body whenever you are outside. So it's the form of radiation, because without any medium the sunlight is traveling from the space to the earth. Why these three modes are important to know? Because whenever you will be solving any CFD problem, then you need to know how boundary conditions should be applied. So if you don't know in real life scenario how the heat is conducting, or is it a conduction or convection or radiation, then you might set up the wrong boundary conditions and it will give you wrong results. Okay. Next question is, what is convective heat transfer coefficient? So convective heat transfer coefficient, which is generally given by the letter H, justifies that how the heat moves between solid surface and a fluid in motion. So suppose that you have any heating solid body kept inside a water or air, and the air or the water is moving alongside that body, then it is absorbing the heat from that body and getting it transferred through the air or water. So this phenomenon can be this phenomenon can be explained by the convective heat transfer coefficient. And what the convective transfer coefficient depends on? It depends on viscosity of the fluid which is carrying the heat and the thermal conductivity. So it will again depend on the flow velocity and the geometry also, because more your surface, then more the heat transfer and everything, those factors will come in. Okay. The next question, which is very important for any CFD engineer, is what is boundary layer? So boundary layer is the very thin region which is adjacent to solid surface. So let's say that the air is flowing over a flat plate. So a very thin section of air which is very close to that surface, okay, there the boundary layers will be generated. So at the layer of the solid or the surface, the air velocity will be 0. At exact surface the air velocity is 0, but as you move away from that surface, your velocity will gradually increase. So when this gradually increase of velocity happens, that transition region is the boundary layer zone. After this region, the free stream region comes up where the velocity will be constant. So within this layer there are viscous forces which are acting upon the fluid motion. So the behavior of this boundary layer should be captured in order to study our phenomena or study our fluid flow motion. So these boundary layers affect the drag, heat transfer and the flow separation phenomena. Okay. Then the next question is, why is capturing the boundary layer is important? So whenever the boundary layer is in place, so it will control some of the main fluid behaviors, which are skin friction, drag, then heat transfer rate and flow separation. So if you do not resolve the boundary layers, if you wrongly create the boundary layers, then what will happen is your drag coefficients, your heat transfer and flow separation, these phenomena will get wrong. So for example, if you are performing a CFD of cooling of some body, okay, then and if your boundary layers are wrong, they are not capturing your physical phenomena correctly, then what will happen is your heat exchange will be wrong, and as your heat exchange is wrong, your CFD will be wrong. Hence it's very important to rightly capture the boundary layers. Next question is, what is Y plus and why is it important? So now Y plus is the concept which is related to the boundary layer. Okay, how I will tell you. So Y plus is a non-dimensional number. It represents a distance of first computational mesh point from the wall in wall units. So whenever you create a mesh, you will generate a boundary layers close to the wall body. So when you create that boundary layers, the distance of that first mesh cell from the wall, this distance is called as y plus. So whenever you want to capture I will say whenever you want to resolve a boundary layer, you need to have the very low y plus. Okay, so explanation is that if you have very low y plus, you will directly resolve a viscous sublayer. Whenever your y plus is high, you have to use the wall functions properly. So wall functions which we use generally are k epsilon, k omega, etc. Okay, so if you don't have the y plus correctly, then you will skip that transition zone where the fluid is resisting against the wall for the flow. Okay, so if you wrongly predict that, then again all the parameters will go wrong. Hence your mesh should be fine near the wall such that it should resolve the boundary layers properly. So generally for wall functions, okay, which are k epsilon, k omega and everything, the y plus which is recommended is 30 to 300, and if you want to accurately predict the boundary layers, then it should be almost close to 10. But if you want to resolve the boundary layers directly, then your y plus should be 1. Okay, so there are many online calculators which you can use to calculate these y plus. Next question is, what is wall shear stress and why it is important? So wall shear stress is the tangential force per unit area exerted by the fluid on the wall. So whenever there is a fluid flow over a wall or over a surface, so due to the viscosity of that fluid, there will be a force which will be applied on the walls. This force is called as wall shear stress. So this force plays a key role in determining the frictional drag on objects, which is like airplanes, cars or pipes, and it can also cause the energy losses. So accurate predictions of wall shear stress is essential whenever we want to design a system where we want to minimize the drag or maximize the heat transfer. Thank you for the listening. This was our part 1 for the interview questions. I will get back to you with the part 2, and best of luck for your interview. Thank you.